Last week I was attending the Build conference, so I'm happy to be back. It was a very interesting week, so we had some great announcements also regarding Service Fabric, and I'd like to start with a little primer, not directly with agenda that I put together for today. I'm going to start with a little bit of a motivation why microservices is something that you should consider using in your projects and when, and a little bit about actors, what role they can play. This is quite a, let's say, interesting kind of model to program. And then we will continue to look at how you can modernize your existing or new apps with microservices using Service Fabric. And then we'll have a little bit of a fly-through of different features and demos, and also how we can use Service Fabric not only for hosting your code, but also for hosting existing, let's say, executables, containers, and what's the roadmap for the next, let's say, few months is regarding all those topics. So let's have a little bit of a introduction of what are the problems that we usually face when we try to run software at big scale. So we have mostly the problem of scaling, and we'll start with a little bit of a, let's say, review what usual projects that I'm looking at with customers look like. And most of the time we're talking about 3 different scale dimensions, which is we have possibilities to scale horizontally, which means we can just add more machines. We have functional scale dimension, the y-axis in this case, which means we can increase the machine size. Basically what we do is we increase the size of the project, we increase the size of the functionality and the requirements of RAM and CPU, and what we do usually is we increase the size of the machines to fix that. And then we have the z-axis, which we look at, and when we talk about how can we store data and how can we partition data to be stored in a more efficient way and to make it accessible faster and more efficient. So what we are faced often with are usually 3-tier applications, which are usually consist of 3 layers, which is the first is the front end, or you could say service layer. Sometimes it's APIs. Then we have some sort of a data backend consisting of a data access layer or a logic layer using data access directly to a database. The reality, however, is that most of the time, actually when we analyze existing applications, is that the first 2 layers are actually running in the same process very often. So there's very, very often just one process, and then there's everything in one big bucket. And then accessing the database directly. So how could we scale this kind of architecture? Well, there's a few things that you can look at. Of course, you can try to scale horizontally, which is what we usually do. So we add just more front-end layer machines, and then we also can scale our database. So this means we have different dimensions here. So we have the X dimension, adding more machines, and then we can also scale the Y-axis, which means we can increase the size. And also, if we have to add more functionality to our application, this is something that will usually happen. So what consideration we do is sometimes in a service-oriented architecture, we just split services into several, let's say, instances and separate out concerns, like we have one system that takes care of the users and the other takes care of accounting, and the next one takes care of another functionality, and all these systems might have different databases, for example. So this is one way you can do it, but this is obviously not the best. So what we can also try, we can scale horizontally and then add another layer, or we can try to partition our data to be more efficient on a database layer. And then this causes also some problems, because the database system has to support this. And if you look at traditional databases like SQL, MySQL, you usually have master and slave situations where you don't have the same performance when you want to write or read data, and you have some, let's say, partitioning problems. And obviously, this is not an easy task to run such a system and to maintain it and to keep it in sync. So we will have some problems here at the database layer if we have situations of high load. Specifically, if we have high read and high write loads at the same time. And of course, because we are IT guys, we find solutions for such problems. For example, if we have to manage high read loads, we do sort of a distributed cache solution where we put, for example, a Redis cluster in front of our database to cache all the read requests to make that read faster. But we still have to write something to the database, and this goes around the cache, of course. So we still have to write directly to the database, and we still have the same problems when we have a high load in terms of writing to the database. So this will cause problems at some point. And of course, you need to keep your cache in sync. You need to think about how do you clean the cache? How do you make sure that always this, let's say, the most recent data is in the cache? So these are problems you have to fix. Well, we are IT guys, and we found another solution for that, of course. And we are using a write queue. This is sort of a, let's say, pattern that you can use if you want to, let's say, take out the risk of write access or writes blocking your database. So what you can do in such a pattern, you can write all your write requests to a queue, and then some sort of a worker process takes care of these write requests, and then looks at the database load, and if it's appropriate, it syncs them into the database. But this will cause, of course, another problem, because then you increase the lag between something written into the queue and then being in the database, and then at some point later in the cache. So there might be a larger delay actually on that. So it's all solutions, but it's not really the best. So what can we do better? Well, we can use microservices, sort of a approach to fix those problems. And this means we are separating by functional requirements. Yeah, so we take functionality and split it into different smaller blocks, which are, of course, easier to understand. So there is, let's say, some people say, okay, a microservice usually should not be more than the number of lines of code you can see on one screen. Yeah, there's people who say that. There's others who say, okay, microservices can be much larger, and actually they can be whole programs with a lot of functionality. And they also claim, some people claim, okay, Docker is a microservice, which I don't really believe so. I say Docker is not really microservices. Docker is a DevOps approach to fix certain problems, how to get your code into production. And if, of course, it can be used in a microservice approach, but it's not really small. If you look at Docker containers, usually they contain a whole operating system, at least the binaries for that, and then they're not very small. So actually, the microservice approach, from my standpoint, is you have really a few lines of code, and these take care of a very specific problem, and that could be considered a microservice. And that can run in a high density environment, so you can have hundreds or thousands of these code blocks running on the same machine. Whether small machine or large machine doesn't matter, but you can have a much higher density of code running on your machine if you compare that to having many Docker containers, where you have a large overhead for each of those containers, of course. Well, let's define microservice up front. We say a microservice is something that's bundling your logic and your data, so in one place. And this is very important. Really means the same place means it's really in memory at the same location than the logic. So it's not separated out. It's not in a database. The database is really only there to snapshot the data. But while the application is running, your data is near your code, so as near as possible. And when you want to scale such a system, you have several ways how you can scale it. So first of all, you can try to increase the functionality, but we don't want to do that, obviously. So when we want to scale a little microservice to the next level, so we want to add more functionality, we will not just make this service bigger and add more functions to that one specific service. We will create another service, which is also small. And this is the kind of scaling we want to achieve. And then we can interact between those different services by calling functions on each other or sending messages. And when we want to scale a single service, let's say we need more power, we need this service to cope with more data, we will just add more instances of the same services to this cluster. So this case, that way. So if you look at the data again, you see here the data is basically inside of the same service instance, and then it can be snapshotted down to a database to have sort of a backup, but the cluster itself takes care of failover and data and resilience and all these problems. And so having it in a local database system is not our main concern here. This is taken care by the cluster system. So if you think about what that means in terms of complexity, of course, this is, if you start with a project, it's a bit more complex, of course. So it has some obligations on the team to set up all this and to maintain it. And then when you continue with the project, you will get the payout. And if you start with a monolithic approach, of course, you can start easier. You will have a lower complexity, but once it gets more complex, you will lose productivity basically because of that monolith growing and being more complex, and you cannot really scale it well. So you have to find workarounds. So you really start investing more and more time because that solution is so complex. And if you continue with microservices, you might also lose a bit of productivity, but the payout comes, let's say later, the more complex the project goes over time, you will really see increased productivity compared to the monolith approach. So let's have a short look at pros and cons again. So we have, for the microservice approach, we will have some cleaner architecture because you separate out concerns into different services. We can do more independent deployments because there's you can configure, let's say, what's in this specific deployment. So you have several parts. You can say this part is important for this deployment. Other parts you may skip. So you have modular approaches. You can scale, of course, our main concern. And the cons is it is a distributed system, which is something that needs to be looked at. It has to be resilient against any sort of disasters. And you have a large, so you have an increased management overhead, specifically when you look at the start, when you have to set it up and you get it going. But we thought, okay, there is sort of a payout if you continue using it. So what about the actor model? What makes this one specifically more useful than other models? So when we talk about microservices, means we have code and data in one place. So what's the actor then? Well, it also encapsulates logic and data. It lives in the RAM, but the special thing about it is single-threaded. So it's really like, it's not a service that takes multiple requests at the same time. It's more like you have a queue of messages coming into that actor, like actions that this actor has to perform, and it will take these messages and these function calls, which are single-threaded, and work one by one, and then persist the state. So it's sort of a state machine, and so a state machine cannot be multi-threaded. It has a specific state, so it will change over time. But it is, let's say, an object that has a state, and that's something like, I could say a person object, for example, is an example. A person lives in that actor model, and all the information that belongs to that person is part of that actor. And it's obvious that you don't want to change two properties by two different services at the same time. So you want to have a consistent state all the time. That's the idea of the actor. To implement that, you have a lot of choice. You can use several frameworks and host them in several different environments. You can use Acronet or Elixir, where everything is an actor basically. Acronet is an open source framework where you have full control, obviously, over everything, but you are also responsible for hosting it and maintaining it, and it can be used with Service Fabric. And we have the project Orleans, which is the Microsoft research approach to the actor problem. It has been tested with several projects at Microsoft, like Hitman or Halo are running on actor model, and it's also runnable on Service Fabric. And then we have Service Fabric as the hosting cluster or the hosting model for these frameworks, which is basically, you could say, this is Kubernetes on steroids. So you have an orchestrator and an actor runtime at the same time, and you can also run Docker containers and code, a microservice code at the same time on that cluster. And it has been also tested in Azure, so I come to that later a bit. So also Microsoft is using Service Fabric for several Azure services to host them. So it's really a proven concept that works. So what about, let's say, the state and the future of the Service Fabric? So we have it. So it's basically a solution that runs on almost any machine, on different operating systems. It runs on your dev box, of course. It runs on Azure. You can host it on-premise if you have your own data center, and you can also install it on other clouds. So that's your choice. So you're not really bound to using it on Azure. That's a good thing. And also what we added is support for Linux, which means you can run Service Fabric natively on Linux, and you can host your code and your Docker containers in Azure Service Fabric. We will have it available to use it on-prem this year, so it's not yet available to download for your own machine, but you can test it out on your dev machine, and you can test it out on Azure. Then for your on-premise, it's also available on coming to Azure Stack, which is a special offer by Microsoft, where you can basically run Azure in your own data center. So the other solution here is to run it on your machine, but that's not Azure Stack. Azure Stack means you really want to have an Azure functionality in your data center. It has the same kind of portal, the same kind of orchestration, and then you can also, in the future, you can also run Service Fabric on Azure Stack. So what kind of programming models are available currently? So we have several kinds of ways how we can host code in Service Fabric. So you will have, for example, containers, existing containers for lift and shift scenarios. You can just go ahead and use your Docker containers or Windows containers and host them in Service Fabric and orchestrate it. You can have simply get executables. What we say is you just have an exit file or a binary that you usually would run as a service on a machine. You can put that into Service Fabric and host it there, and use all the orchestration power of Service Fabric to host your existing exit files or binaries, basically. And then you can, of course, create new services or take code from your existing project and put them into reliable services, depending on which model you choose, either as a reliable server with or without actors, and with or without a web front end or an API, which would be ASP.NET Core in that case. So you have all the choice that you need, and for building your applications, you can use Visual Studio and Jenkins with Eclipse. So we have also a lot of choice there. And as I said, we are also Microsoft is using this framework to host its own Azure services, or at least a good amount of them on Azure Service Fabric. So like SQL database, for example, if you take Azure SQL database, it runs on Service Fabric. The document DB, now called, so it has been renamed to, I think, so I have to look it up. So it has been a rename at the Build conference. And then we have IoT Hub, Event Hub, Skype, Cortana, and other services run on Azure Service Fabric. So it really has quite a history, and it's quite stable, and Microsoft bets on it too. So it's good to use. Yeah, it has been renamed to Cosmos DB. That's in the slide here. 30% of the services run there, and it's really designed for critical workloads. So how can we use it to modernize our application development? So there are several steps. We have a traditional app. We like to host, for example, a guest executable or container, and then we will take that application and split out or create new microservices, adding them to, let's say, the existing application to enrich it with new functionality. And then this would be, let's say, a lift and shift scenario first, and then maybe changing the way how it behaves or splitting it up. And the next steps would be we take existing code blocks from the legacy application and take them into microservices. So to really modernize the whole experience. And then at the end, the ideal would be to have everything in microservices, of course. So let's have a look at the guest executable or container approach, which is the most obvious and the first step for a lot of people. We can use the container approach to host your code. Obviously, you can use different operating systems. If you run it on Windows, you can use Windows containers, and if you run it on Linux, you can Linux Docker containers. So there's currently not there's no mixture possible currently, so you can not run a Linux Docker container on a Windows server with Service Fabric, and vice versa. It's also not possible. So you have to choose what's your base platform then, and what kind of code are you running. And then you can basically build your containers and run them in Service Fabric. So we have a legacy application like an IIS ASP.NET frontend and a backend, and then we could put them into a container with using Docker Compose and run that in the Service Fabric cluster. And the cool thing here is you have an internal DNS service that is used to resolve the service names. So the first service, for example, can use a DNS name to access the backend API of the second service, and the resolution where the service is, so the IP address and the port, is done by the DNS service. So you don't have to take care. So these services don't have to know where the instances are actually running, and that's a good thing because you want to have failover, and basically the cluster should take care of where, on which machine, which service runs, and how often it is instantiated. So the legacy application then accesses these services, and you can expose them via port forwarding or other mechanisms where we see that a bit later. So then, when we have done this step, we can go to the next level and say, okay, how do we add new functionality to the existing microservice or to the existing Docker functionality? So we have let's say we started with a Docker Compose approach and took 2 Docker containers, running them in the Service Fabric cluster, and now we want to add 2 new services. Then we can move that over to a different application definition, which is a Fabric application. And that Fabric application can run several Docker containers and also new microservices, for example, written in .NET Core. So that's what you can compose then. So we switch over from Docker Compose to the Fabric application, which is having a bit different configuration files, but in all, you can use the Docker containers unchanged as they are. You just have to define a new configuration basically for this scenario. So for example, if you have a simple web app, coming back to how we host executables or let's say existing code, usually what you have, if you have a web application, in this case a ASP.NET Core application, it's simply a host process, which is an entry point and starts the web host, and then your pages get served by either Kestrel or the web listener. And then you can basically host it today on any server this way. If you take that to the Service Fabric, you can have two choices. You either run it as executable, basically, or you can convert it into a reliable service, which means you take the code and then put it into a new Service Fabric project and then add some more, let's say, intermediate classes, which help you run this as a reliable service, which means you have more control how it is really clustered, how it behaves. And it can take all the features and can use all the features that the Service Fabric framework really offers. Like you can make this service, for example, into a stateful service. So having a, let's say, a stateless service means it doesn't have any local data store, and you convert that, for example, into a stateful service which has some state, which is then replicated over all the instances of the service. So it could be a scenario that you want to go for. So when you want to access the service, there's also something new which is quite interesting. Just want to go into that very briefly. You have the Service Fabric, and then you want to expose several services to the internet. So how you do that usually is exposing ports, or you can use directory mappings to map to different services. That's one way to do it. That already exists. So it really works, and you can do load balancing and all the stuff. But there is another, let's say, new feature coming, which is using Service Fabric together with the Azure API management, which means you take your service and then expose different routes to the Service Fabric. So you can say we wanna add a route to access a service. We wanna have a route that accesses a specific petition in that service.
Can I interrupt you for a sec? Yeah. There's one person that has a question. I was just wondering whether you would prefer to go ahead and ask it before they forget, or whether you like to wait until the end. I know that's a little bit awkward, but
it depends. So I think I will be through with the presentation anyway in a few minutes, and then we can do some questions, and then we should have a look at the demo.
Okay, then we'll just wait. We'll wait till you're through then, and then maybe we'll do it then. Yeah. Sorry. Go ahead. Sorry to interrupt.
Okay. So this is so you want to expose several layers in your functionality. Like you want to expose one service which is behind a load balancer, then you will have one route there, and so probably there's situations where you want to expose a specific instance of that service. You can also do that. So all sorts of routing can be done with the API management. And one sample how you could do that is basically you have several kinds of services running in several instances, running under several Service Fabric addresses internally. And then you want to build a service front-end layer, basically, that takes different REST methods and forwards them to different endpoints in your Service Fabric. And this is something that you can do now with the API management. So you could say, every time I access the web UI, it goes to the index directly. So if you do a get on the slash, it goes here. Then if you do a post to a specific address, it goes to another service. If you do a delete and get and however, you can separate that this way and say you define for every kind of REST method and REST URL, you can define where this goes into your clusters. And you can say, I have a central endpoint. That's the good thing. You have one front-end certificate basically to secure all this, and then you can route internally. So that's the idea here. Coming back to the programming model, just to give you a brief flavor of what's there, what's coming. So we have your existing .NET code which you can run. You can run it on ASP.NET Core. You can use reliable actors, reliable services, and run guest executables and containers on Windows. So that's what's there today. And then we have a preview for Linux, which is currently also available in Azure, where you can run .NET Core code and also executables and containers. And the future will be that we will move on to use the .NET Standard 2.0, which was also announced at the Build conference, to bring together at least most of the .NET part to be usable on both ends. So meaning you can run your .NET Standard code then on Linux and Windows without any changes. And of course, the guest executables have to be somehow compiled for the target platform. That will of course be the same. And the container thing is still not clear to me if there will be, say, Linux containers on Windows or Windows containers on Linux. So no words on that, and then we will see what happens there. So that's it for this part. In the presentation, there is a lot of links and hints to different documentations in our portal GitHub projects that you can look at, and of course several sessions at the Build conference that you should have a look at too if you're interested in migrating existing code or creating new stuff. So we can now open the first question round if you like, and yeah, just go ahead.
Hello, Daniel. Ismail here. Just a question. A couple of slides back, you were transforming actually your Docker containers into Service Fabric, right?
Yeah.
So I think it's like 5 or 6 slides back. And then you have to create an application inside the Service Fabric where host your containers. Could you just clarify it a bit more? I was just confused a bit.
Yeah. So coming back to this slide, basically, this is the
exactly. You're moving things from Docker Compose to your application on Service Fabric.
Exactly. So you can start with Docker Compose. You can take the YAML file and start that right in Service Fabric. So that's the easy approach. So let's say probably most obvious thing to do if you have existing Docker containers. And then if you decide to say, okay, I want to compose a larger framework now, so I want to extend that application with additional services, you can, of course, extend the Docker Compose file and then make that larger and add more Docker containers. And that's absolutely valid to do. There's nothing will keep you from doing that. But you can also choose to say, okay, I will just use the existing Docker containers and then add more microservices written in .NET and put this all together in a so-called Fabric application, which is basically the same as the Docker Compose, but it has a little bit different configuration file. Yeah, so it's all XML based, and so you can define the same Docker containers in that application definition file, and also the same kind of port mappings, but you can also add these reliable service on the actors, for example. So that's the transition. So it's just a shift from one configuration to another one, but the functionality is basically the same. We added the left side just to make it easier, basically to kick off your project. Yeah.
And another question, can I mix Windows-based containers with Linux-based containers in one Service Fabric cluster?
No, not at the moment. It's not possible. You can only go for one, and you have to decide which architecture, which underlying operating system you want.
Okay. And what are the minimal costs for one of the Service Fabric clusters? Where does it start?
There are several recommendations. We can have a look at it. Better we go to the portal and have a short, quick brief on what is there. So if you go for a new Service Fabric cluster in Azure, you basically say, I want a new Service Fabric, and then you have let's have a look at the existing one. we have to do too many steps now. So we can have a look at what is the nodes that we are running. And we have, in this case, we have, for example, 5 nodes. And we usually say, okay, you can start with 1 node, which is a development scenario. If you go for 3 nodes, that's a, let's say, minimum requirement to have at least a basic failover. But it's still not optimal. So we say the best thing is you start with 5 nodes. They can be small. So better go with smaller ones and more of them. Anyway, that's never a bad idea to have more instances of smaller instances than having fewer larger instances, unless you have really the requirement to do that because you need so much memory in, let's say, one specific location. But the idea of the microservice approach is, of course, that each single component is very small, and so you can split them very easily onto several machines. Yeah. And then we have larger, so that we have sort of a bronze, silver, gold, and platinum level, which is basically 3, 5, 7, and 9 recommended servers. And yeah, that's what you can do. But you can also say, I want to run a server which has a silver level like this one, and add 20 more machines to it very easily. And these different kind of levels are also connected to having separate kinds of machine types. So the basic level has, let's say, the A types in Azure. The next one has A and D types, and the premium level gives you also the G machines and the large memory instances, which is basically something that you can choose from, and then you can decide what to go for. You can also mix, which is also cool. You can say, I want to have different types of nodes for different types of services. So you can choose to have one scale set. In this case, it's a scale set of D1 machines for a specific workload, and then you can add another one, which maybe a completely different kind of machine type, a different kind of number of machines for another scenario in the same cluster. So you can then decide which service to put on which type of machine because of certain requirements, right?
Okay, one node is one VM, and I can choose which VM to use.
Exactly. You can say, I want to have one cluster with all the same kind of nodes. That's the simple approach. And this type of node is, for example, a 2-core machine with 7 gigabytes of RAM. And then you can say, I want to have 5, 9, 20, 100, 1,000, 1 million of these machines. Doesn't really matter. And you can also say, okay, I want to have 10 machines of type 1 and 10 machines of type 2, because the second type is something
that I can add and add and add. I asked for the minimal thing.
Yeah,
I can start.
Sure.
I can start.
So minimum, I said 1 machine for development, 3 machines for a very basic cluster, but 5 machines is the recommended minimum amount. We would say, okay, go for it for production use.
Great, thank you. I would have another question. I was wondering about dynamic scaling of nodes and services. Is that possible?
It's possible because the underlying scale architecture is using virtual machine scale sets. From if you set up the cluster in the portal with mouse and keyboard, there will be no auto scaling enabled. But you can, of course, automate the deployment of a cluster, and there you have much more control. So you can really put in rules like CPU load, memory usage, time-based scaling, whatever you name it.
So also like depending on the current load of the service, that it would automatically scale.
Yeah, absolutely.
Great, thank you.
But that's a functionality of a virtual machine scale set. So it's basically not really something that Service Fabric adds in, but it's a Azure feature basically of that that kind of resource here. Any more questions?
It doesn't look like it, Daniel. So I guess I'll just throw out what it.
Sorry?
No, there are no more questions. So I guess we can move on to the next part.
Yeah. So we're coming to the point where I want to show you some demo, or at least some code, sample code, how you would create services and how you would handle the cluster and deploy stuff on it. So what I've done, I set up this little cluster here, which is a machine of, I think it's a of 5 machines, as we see, and it's running on Windows. And currently it's looking fine. We can have a look at the dashboard, which is also something that Service Fabric brings. We have this little Explorer application, which every cluster runs. And you can see the whole cluster health here, how many nodes you're running, how many applications we have deployed, and then we can drill down into all the nodes individually and see this application consists of 2 services, which are stateless web applications. One is a web front end and the other one is a web API. And these are running on the different nodes, and you can drill into that and see, okay, this node runs on 2 services, and basically every node runs both services for now. And we can have a look at the Visual Studio project, which is also here. So we should probably increase the zoom level a bit. Basically, it's a very simple setup. You have 2 projects here, which is basically a let me check that for you and zoom in a bit. No, it's not working for some reason. Why is it not working? Okay, zooming doesn't work for now. So we have a web application and we have a web API application, and we can have a look into that. Each of those applications is a Service Fabric application, which you can easily add with a wizard. So you can say,
Daniel, sorry to interrupt. Could you magnify your screen just a little bit? Yeah.
Okay,
that would be great.
We can try to do that. Let's see if we can zoom. This is, yeah, I mean, we can try the loop. I'm wondering why it doesn't work in the first place. Let's make the whole thing.
If we don't have to look at the code, then it's not that big of a deal anyway. But
we can try to make everything larger. Probably will get a bit blurred, but it should be at least larger.
It's good like that. Yeah.
Yeah. So so we can add new types of services easily to the project. Like we have the stateless service, which is basically a piece of .NET code running in a loop. So it could be considered as sort of a Windows service, similar to a Windows service or a Linux daemon. Yeah. And then we have a stateful service, which is basically the same, but it has a replicated state, which means you have an array of properties which you can change, which you can add stuff into, and all the changes get replicated over all instances of this specific service. So anywhere this thing runs, it will always have the same state. And if one node goes down, that doesn't matter because it's always replicated and safe. And then we have the Azure service, which is, let's say, the next level of that, or another purpose service. It has a state, it is replicated, but it has also some other things like when you have millions of actors in a system, which is in terms of a gaming cluster, for example, you have a lot of objects which are actors. Like we have a game that's every single object that you can see on the screen is an actor. Like, for example, if you fire off a shot, this shot itself flies through the screen and flies through the universe, and this little, let's say, bullet is an actor. And you can imagine that this is kind of memory intensive, and sometimes you don't need every actor to be in memory at the same time. So what the actor model also provides you is an automatic, let's say, unloading of unused actors and persisting them. Which means if you have a few million actors and let's say only 10,000 are active, it unloads the rest after a certain period of inactivity time, and then once you try to access that actor again, for example, sending him a message, it gets reloaded, the state is again put into memory, so re-instantiated basically with the old state, and then it just runs its code, and if then gets inactive again, it gets removed from memory after a while. So it's really like a combination of all of these things here. And then you have the things I already shown you, web APIs, web applications, executables, containers. You put just, for example, here you just put in the name of a Docker container and then in Docker Hub, and you can just start it. So if I put in WordPress here, it will just run a WordPress instance in the cluster. So really fairly easy. And once we have it all set up, we can just deploy it. And we can either decide to run it locally, which means we have a local one node cluster. Of course, that's a bit limited depending on your developer machine. And we can also try or decide to publish it to the Azure cloud or your private cloud, depending where your cluster lives. And then you can just say, okay, where is my endpoint? You can just log into your Azure account, you just choose your cluster and go for it and say, deploy this application now. To make this work, we need to change at least the version, because we want to upgrade from version 1 to version 2. So it means we have to increase the version at least by 1 digit here, and then we can go for the deployment and publish it. And then if you look back at the cluster, what happens is it's automatically upgrading from one version to the other. And if something fails, and that's also a cool thing, you can see that the package gets downloaded now. If something goes wrong during the deployment, it goes through different upgrade domains, how we call it. And in this case, we have 5 different upgrade domains. You can see it easily here in this overview. So if you look at the cluster map, you see, okay, we have 5 different fault domains and 5 different upgrade domains. And what the cluster automatically does in this scenario, it takes this package and rolls it over the different upgrade domains. If something goes wrong, it rolls back. And that's something you get for free. So if you do something bad in your code, for example, your new version crashes all the time, the cluster deployment process will detect this, and it will look for errors during the deployment, and it waits for a configurable amount of time. For example, in my case, it waits for 10 seconds until it decides whether this is good or not good. And after this time, it starts rolling to the next upgrade domain. And if it goes wrong, then it's reverting this process and installing the previous version. So you can really be sure that only things that run well really get deployed to production. So that's something that you get. And then you can also see in the cluster map which service basically is hosted where. So if we have more nodes, we can drill down into that and see, okay, this is running here, this is running there, which node is in which domain. And you can also see when nodes fail. Basically what we can try now is we just go and restart one of the nodes, which that's better we do it here. Let me just check where I could do this. The most easy way, I think we should just restart one of the nodes here. And once this happens, you will see that the cluster starts failing for one node, and also the rollout could probably fail. But I think we are already over the first node, so it will not fail in this case. But if I attempted to restart node 2, for example, at this very specific moment, probably it would do a rollback because it fails. So it's only working if your cluster is also healthy. But you can decide what happens. You can say a rollback. If something goes wrong, you can say stop the whole thing. If it goes wrong, you say I want a manual interaction if it goes wrong, so you can decide what to do. All things are possible here. Yeah. Okay. So that's basically just to give you a quick overview how the tooling works. So as I said, adding project here, quite, let's say, straightforward way. You can also debug your cluster from here. So currently we are doing a upgrade, so I can also just stop this. And I can also say, let's have a look at the Service Explorer, the Cloud Explorer. Hopefully it comes up. And then you can see we can also attach to an existing cluster in Azure and start debugging into that. So you can start just say, I want to attach to a process that's currently running in my production cluster for some reason. It's not giving me this. Try to attach here, but I guess we needed to. Probably will still work, but there's a new Cloud Explorer in Visual Studio which is currently not working for me for some reason. But you can just go there and say, okay, I want to attach to the process, and then start adding breakpoints, and then just stop there or debug it in production. That's fairly easy, and of course you can do all this on your local machine too. Of course, that's much easier. Do you have any questions so far?
Oh. So there are no questions here, Daniel. Yeah.
Okay. So this was basically what I've shown you here was a very, very brief overview of what was shown at the Build conference and what we did in another talk a few weeks ago. So if you actually need to, you might want to look at the whole talk, which is available online. And also there is a few other interesting talks from the Build conference, specifically going deeper into the topic of hosting ASP.NET Core in Service Fabric, and also deeper into the into the problem of Docker containers, how they are configured, how you can run your own, for example, Docker repository and stuff like that. And there's also a lot of good sample code available to get you a quick start. For example, if you want to see how a cluster of front-end, back-end, and several other containers run together, you can just go and for the quick start templates and deploy them on your own machine and see how that works out. So it's really good content available there. And it's at the end of my presentation. There is all the links, and I would suggest two things now. So first one is I will send you the presentation, Scott, and you can spread it in your group if you like. And also I'll switch back to my first slide here. Just go ahead and write down my email address or my Twitter alias, and go ahead and ask me questions. I will answer all your questions if you have one. If you still have questions, you can really contact me anytime. I try to answer them on time or as quickly as possible. And if you have the need for, let's say, further consulting in the direction of how do I go with this or that application into the Azure cloud, or what would you recommend me to do in terms of the architecture, we can also talk and probably also arrange some session about that. So that's not a problem. We do that every day.
That's wonderful. So, Daniel, the only thing I think I have left to say is that I hope that the next time that you're here in person in Freiburg,
I hope too.
It's not as big as Munich, but it certainly has a lot to offer, and hope to see you soon.
Okay.
Thank you.
See you there. Bye-bye.
Bye.